If your LattePanda is running in the same room where you normally stay at, maybe you notice that after some time the fan gets a little bit annoying. Well, at least it does for me. And it is annoying, especially knowing that, well, at least my LattePanda is not working really, really hard. So this fan could work much less to achieve the same result. So I wanted to find a way where I can, well, I wouldn't say disable this fan, but make it temperature controlled. So it only runs when the CPU is working really high and it gets really, really hot. So in this video, I'm going to show you how to do it with a little bit of electronics, a bit of programming, and of course with Node-Red. The idea to implement this solution came to me after I found this article on Hexter.io. It talks about how to do, cooling on a LattePanda. So this guy is using exactly the same hardware as me, but his solution is slightly different from mine because, he's not using Node-Red and he's not using a PWM control. But the original idea and the way to get the CPU temperature is actually his. Because when I started looking at how to get the CPU temperature, there is something in Windows which is called the WMI. I think it's Windows Management Instrumentation or something like that, where you would normally get physical details of your computer. And for example, you can get the CPU temperature. But in some computers it doesn't work because it only stores the CPU temperature when the system was booted up, which is obviously not really useful. And of course that doesn't change, so it just keeps that value, which was, for me, it's 20 something degrees, which was obviously incorrect. So what this article talks about is that there is an application, there is a program which is called the Open Hardware Monitor. And I've actually found that separately. I've downloaded that, and it shows me all sorts of information from the system, like how fast the processor cores are running, what's the temperature, even the clock speed and everything. So there is a lot of info. Oh yeah, you can see it here. So there is a lot of information here. But what I didn't know about is that the Open Hardware Monitor contains a DLL which you can call to extract all that information. And this article talks about how to build a console application in Visual Studio 2017, or just basically Visual Studio in C# that calls the Open Hardware Monitor and extracts the data. And his solution was to extract just the temperature values, and then using that temperature value, talk directly to the Arduino, and then basically flag a pin on the Arduino to turn the fan on and off. So what I decided to do instead is, this console application is not going to do anything, just output the values into the standard output, and that I can pick up from Node-Red, and from Node-Red I can talk directly to the Arduino, and again use one of the physical pins to control the fan, but also control that with PWM, not just simply switching it on and off. Okay, so yeah, as you can see, he had a really simple setup or control concept, which basically says if the CPU temperature is above 70 degrees, that turn the fan on. I mean, it works fine. I just wanted to have something where I can, rather than have the fan come on and off from time to time, I can just run it at a lower speed, so it constantly cools the LattePanda, but it's not loud at all. So anyway, I've gone through these steps, so you don't have to have installed Visual Studio. I've done the program and everything, and you can get the same program. I will put the download link in the video description, and basically my code contains a getCPUTemp.exe and contains the DLL for the Open Hardware Monitor library. To run this program, I have to open a command prompt in administrator mode, because that's I need these privileges to access the library and probably have access to the physical details of the computer. Well, that's just how it works. So if I just execute cputemp.exe, the output is going to look like this. So as you can see, it is in JSON format, and I have a couple of details. So I have an Intel CPU 0 load 1, load 2, load 3, load 4, and also load 0. So these are the load on the individual cores. So as you can see, 2 of the cores are not doing anything, the other 2 cores are running 50%. So the overall load in the system, which is CPU load 0, is 25%. And we also get the Intel CPU 0, temperature 0, and then CPU 0, temperature 1, temperature 2, temperature 3, which are the temperatures of the individual cores. So LattePanda, the Atom processor, has 4 cores, so we have the temperature of each of the cores. As you can see, 2 of them are slightly warmer than the other. So that's the information I'm going to work with, and what I will get at the end. So this is the flow which is running on Node-Red at the moment. Is I created this system tab. Again, the whole flow for this one is also going to be in the video description, in which I have reused one of the existing components. So there is a system information node and some flow available in Node-Red. And unfortunately, some of them, for example, the CPU load part of it doesn't work because it was mostly designed for the Raspberry Pi and Linux. But we are still getting some of the information. For example, the system information panel, which shows the uptime, the cores and everything. And then we also have the memory, which is also working fine. And the temperature and the CPU load is something that I have added. So here we can see all the 4 cores, and I've taken the first core as an example here in the gauge, so we can see it in slightly bigger bigger number. At the bottom of the screen we see the fan PWM signal, and that's the value which is controlling the fan. So what I have said is, if the CPU temperature is below 50 degrees, then well, I don't need to run the fan at all, and from at 50 degrees the fan turns on, and then basically it reaches maximum speed at 70 degrees. So that would be, you know, PWM 255. And if you look at the editor, that's how the entire flow looks like. And part of his flow is from the system OS node. And as you can see, I have installed them here. So there is this OS node which gives you a couple of nodes where you can query drive, CPU, uptime, and the other things. As I said, some of them are not working on Windows. I've already removed them. And I have added my flow up here, which is calling this exe, which gets the CPU temperatures and the load, and from that information it generates the temperature and the load, CPU load group, and also does the communication with Arduino. And before I go any further, I just wanted to show that that's the Node-Red Contrib OS is the operating system node. And for the serial communication, I also had to install the serial port, which is I'm using Node-Red Node serial port. So these are the additional 2 nodes that I've installed on top of the stock installation. To go through the flow, I would say it's fairly easy. The original flow also had this single inject node which fires every 30 seconds. So we will get updates twice every minute. And I'm not going to talk about the OS part of it, so you can have a look and see what it does. What my code does is basically every 30 seconds it executes an exec command, which in my case I put my get CPU temp exe into C users LattePanda documents. I've created a get CPU temp folder, and within that I have the get CPU temp exe and also the DLR. So I just call that like this, a simple exec node, and then the output I convert to a JSON format. So once I have the data here, actually, let me put a debug node here. Click. Okay, so we will see, just have to wait a little bit and then we will see the debug here. So from the data which is coming out here, I'm feeding that into the core 0 temperature. Here I'm just copying the data from the message payload Intel CPU temperature 0 into the payload, so the gauge can pick it up. And also I'm putting it into the to the pie chart. And here again in the pie chart, I'm formatting the data so all the 4 CPU temperatures are sent into the pie chart, and that's why it is displaying basically 4 different values. And we got our first message. So this comes from this debug which I just placed here. So as you can see, the message.payload is now an object which has a couple of attributes which corresponds to each of the values that we got out of the exe file. So we have the temperatures and we have the loads as well. Also for the load, I'm doing pretty much similar to what I have done above. I've selected one of the load, which is the overall load. I'm copying it into the payload, so that goes into the gauge. And then all the other 4 payloads get formatted together, so they can get sent to a line chart. And again, they get displayed like this. Actually, I'm not really sure if this is the best way to display that, because since I'm only taking a sample every 30 seconds, usually it really jumps around, so this chart will just become a real mess at the end. So maybe I will eventually, delete this, because it's not, making too much sense to have this, at least not displayed in this type of format. Okay, so these are all about the static displays, and that piece of the flow is responsible for sending the data out and calculating the PWM signal. So first of all, I have a little bit of code which basically selects what's the highest temperature core, the warmest core. So out of the 4 temperatures, I'm selecting the greatest one, and I am using this scale node. I have to say this is range node, and this is the first time I'm ever using this. And what it does basically is like a linear transformation. So I'm converting the temperatures from 50 to 70 into the output values of 80 to 255. So these are the PWM values. And in the action, I have the scale and limit the target range. So basically, if I get temperatures higher than 70, the output is still going to be 255. So that's not going to grow linearly. And that's actually what I want. And I also say that round to the nearest integer. And the reason I have 80, because of what I've noticed that in lower values, the fan doesn't actually spin. So it needs a minimum PWM value. Otherwise, it just physically wouldn't spin. And maybe I need to fine tune it. Maybe I just need to raise it to 100. So at 100, it definitely spins quite slowly. And I think 80 is probably the lower threshold. I mean, if you have a different fan, it might be different for you. Obviously, 255 is the maximum speed. And because below, so this range would give me 80 below 50 degrees, but I want to turn it off below 50 degrees, and that's what I'm doing here. So if the message is less than 50, the message goes out on the first port, and otherwise it goes to the second port. So the first port will set the PWM speed to 0, and the second port would use the range. So the output of these two would go into the UI, which now says 0, and also it goes out here, in which I am formatting this output to say fan, colon, and the actual value. So yeah, so something like this. So this is a string that I'm generating, because that's the instruction that I want to send to the Arduino. And as you can see, the output of this, well, it also goes to debug, so I can see what's happening, and it goes to the Arduino. And even though we haven't talked about the Arduino yet, let me just go over to the serial port settings. So this is the serial out node, and in here I just configured the Arduino. So my Arduino is on COM5. I'm not sure if that would be any different for any other LattePanda, but most probably it's going to be COM5. And in the Arduino code, I set the baud rate to 115200, and I left all of the other settings as default. So that's when I'm sending serial data out. And then I also created this small one to also receive all the data which is coming back from the Arduino, which is simple text like this, command fan value 0. So that just gives me a confirmation that the Arduino has understood the fan 0 command that I sent, and also some of the other messages are like fans being updated. So we will see in the Arduino code what this all means and why the Arduino is sending like this. And for testing, I've just created a couple of manual inject nodes, mostly to test what is the lowest fan speed, which then you can update it here. So that's pretty much it. I mean, it's not really a complicated code, I have to say. And besides this code not being too complicated, there is nothing here which would be specific to my setup. So if you just copy the flow or paste your flow into your Node-Red and you deploy it, then it should work for you without any modifications. Probably the only thing is that if you have a different fan type or fan model, then you can fiddle around with this value. Or if you want it to only turn at 60 degrees, you can change this value and also this value here. But other than that, it should work like this. So let's go over to the LattePanda now. Let me start the Arduino editor. And by the way, now we can see that the core temperature is only 50 degrees. Oh no, we have reached 50 degrees now, so the PWM speed is 80. So now we are starting to do some work on the LattePanda, so probably it's going to warm up. So that's the code that I have written for this very simple fan controller. And in here, on the top, I have just some declaration. So I'm using the fan pin, which is the pin 9. So this is the D9 where I plug the connector in. So the way I've written this program is that the Node-Red is sending all these updates to the Arduino, and because that inject which we have seen here, this one is running every 30 seconds, there will be an update sent every 30 seconds. So in case the Node-Red is not running or the Node-Red is stopped, I wanted to have a fail-safe here. So if there is no message received for 50 minutes, which is 300,000 milliseconds, then the Arduino will set a default fan speed. So again, if you shut down Node-Red, then the fan would still keep running for 5 minutes based on the latest update, but then after 5 minutes it would just switch up to 200. Or probably the same if, like, let's say you start up your LattePanda and it's running Windows updates for like 10 minutes, then after 5 minutes the fan would switch on, because most probably your, well, let's say your CPU is probably toasty and needs some cooling anyway. There is nothing really to change here. If you want to do this, if you want to change this timeout, you can change this value. If you want to use a different pin other than D9, then yeah, you can update it here. But other than that, it should be all fine. In the setup, I'm just setting up all the pins, and I'm defining the serial speed, which is 115200. So that's the same serial speed that we had to, I had to set in the Arduino code as well. Sorry, in the Node-Red serial port definition. And in the loop, I'm just reading the serial port. I'm reading this message, and basically what this code assumes is that you are always sending messages where you have a text and a colon and a value. And the text is called the command, so that's the serial command, and the value is a serial value. The reason I've written it this way, because this Arduino is most probably going to do other things than controlling the fan. So this code, you can send messages to the Arduino via serial to control the fan, and you can send different messages so the Arduino can do different stuff. And well, it's like, more generic. You can just enhance the existing code because it only has a couple of declarations up here and a couple of functions which deal with the fan control, and of course it can do other things in the future. So it checks the incoming message and it says what is my command, what is my value, and this is the type of responses that we have seen here. So the command is fan, the value is 0, that was the last one. Now it says the command is probably now it says command is fan, value is 80. And it calls the function check fan, which basically says, is the serial command fan? Okay, so we need to do something with a fan. and I put the value into the fan pin, so that's D9, and I also put the value into the built-in LED, so that's the blue LED, which is the intensity of the LED is going to mimic the speed of the fan. So that's what I'm using at the moment. And I've also updating a local a global variable which is called fan last update, and that's how I'm going to this is how I'm storing what was the last time the fan was updated, so I know, you know, if 5 minutes has elapsed or not. And also in the loop I'm calling this check fan timeout, in which basically I'm saying that the current milliseconds minus the last update is greater than the fan timeout, so that's the 300,000 milliseconds that is defined on the top. And if this is the case, then set the default speed. And that's it. That's all you need to do. So once you have inputted this code, again, if you're using exactly my same setup, just paste the code in and then you do upload. I'm not going to hit upload now because the Node-Red is already connected to COM5, so I will get an error message here in the Arduino. So what I would suggest is that you first start with the Arduino code, you paste this Arduino code, you make any modifications that you want, and then you upload, and then the code is going to be running. And then once you do that, I can't really use the serial monitor as well, but you can also test the code by, actually, you know what, I can just remove these, so I can free up the Arduino code. Sorry, I can free up the COM port for the Arduino, and now I'm connected. So if I send a message hello, I'm going to get a response that it's unknown command. If I send a message fan 50, then it's setting the fan speed. So 255, it's setting the fan 255. So again, now I have the COM port free. I can just upload this sketch, which I don't need to do because it's already uploaded. And yeah, that's pretty much it. And once you have it, then you just deploy your code and it is going to work. So let me just quickly set up the serial out. I've already defined the COM port and the settings. Arduino, and I need to wire these and also these test ones into it. I don't necessarily need the test ones, but and serial in goes in here. Okay, good. Oh, yeah. I just had to come into the setup. Good, and it's connected, so now it's working again. So again, that's it. This is how the final board looks like. It is really, really tiny. I just used a piece of perf board that I actually cut off the excess here. I didn't have a 3-pin connector, so I just used the 4-pin connector. It still fits in the case, and I'm just not using the last pin. And then basically the pin closest to the edge of the case is ground, next is 5 volts, so those are my ground is black and 5 volts is red, and then the innermost pin is always the Arduino pin, and in my case I'm using D9. When we look at the board, we see only 3 components, just like we have seen on the schematics. So we have the transistor, which is the 2N222 in my case. We have a 1K resistor and we have a simple diode. So connecting them is really easy. You have the ground. The ground goes straight to the emitter of the transistor, so that's the leftmost pin. The data line, the yellow line, goes in through a 1K resistor, goes into the middle pin, and then the emitter, which is the rightmost pin, gets connected to the one of the pin connectors, which then will go into the fan. And then basically 5 volt is connected to the other pin of this connector, and the 2 is bridged by the diode, and the cathode side of the diode, which is marked, goes towards the +5 connector. So simple as that. A couple of bodge wires, and that was it. It probably took me about 15 minutes to solder this. So now I'm going to install the module, and I think my hand is going to be in the way. And I have to be cheeky because LattePanda is running at the moment, so I have to make sure that, you know, I just plug everything in where it's supposed to go. I'm not going to short anything. So as I said, I'm going to use D9, which is the leftmost pin out of these 3-pin headers here. So as I said, I'm going to plug it in like this. Okay, you're not going to really see anything because there are no LEDs on this board. I mean, sorry for the crudity of the setup, but I haven't found a final resting place for the LattePanda. And now I'm going to wiggle the fan connector out of its socket and then plug it in here. And that's it. What I can say, I mean, that my temperature, the core temperature is 51 degrees and the PWM signal is 89. And as you can see, the fan is still running, so it is running at 89 speed, but it is virtually silent. I mean, hopefully you can, this comes through the video, even though my kids are really loud in the living room, that as opposed to what it sounded like when it was running full speed and what it sounds now is completely different. And of course it's going to spin up because it's driving less air, so the cooling of the CPU is less than what it was before. So probably after half a minute, when the next update comes through, it's going to spin up a little bit more, but again, it's not going to be that noticeable as opposed to when it's running at full speed. So that's pretty much it, I would say. Now I just need to tidy up. I just removed the front cover of this acrylic case, so I need to put it back on and maybe use a double-sided tape to just, I don't know, secure these cables and this small PCB, but that's all there is to it. This is how you modify your LattePanda to run much quieter. Thanks for watching, and hopefully see you in the next video.